Record. Okay, so we're starting to record now. Okay. Anybody else checks in, they can just keep up with us as we get going. I can use this to share screen. So I'm going to share my screen with you guys. I want to start off with a little bit of an activity. Okay. So you guys should be able to see my screen now. Do you see my desktop on yours?
Yeah.
Okay. Can you guys just take a moment right now? I know this is kind of a weird experience for us, and I want to gauge where you're at with this. We only have a 45-minute class. I want to address a couple of issues at the beginning. We might not get a lot of teaching done today, but the teaching that I wanted to do for you guys for tomorrow, I've uploaded to a video. Okay, so worst case scenario, you can watch the video. What I'd like you guys to do is actually start off here. Can you go to studentdesmos.com? And this is really, it's not really a math thing, it's more of a survey thing. If you could go to studentdesmos.com and type in the following code, I'd like to keep track of a couple of your answers. Can everybody see that?
Yeah.
Okay.
What's the code again?
Sorry, I
MK3 GPS.
Wait, what do we click?
So you just go to studentdesmos.com in a browser. So you have to, you'll have to minimize or not make whole screen zoom so you can get to a browser.
But it says like class registration software or help disk ticket system. I don't know.
Just go to Chrome or whatever browser you're going to use. Type in student.desmos.com.
Okay.
What words will you use to describe how you feel?
Yeah, so when you get to that, you should get, there'll be a survey for you to do.
Should we sign in with Google or continue without?
Doesn't matter. It's sign in with Google because then it makes it a bit more secure. We've done these before, right? Student Desmos. Okay.
Sorry, what was the code?
So the code is NK3GP6. Do you see it?
Uh-huh. Sorry.
That's okay. Anybody else having trouble getting in? We're good? Ryan's still there. He seems to be gone. Okay. So this is you guys here. Okay, so in a sec, I'll see everybody loaded in. And I want to ask you a couple questions about how you're feeling, and I need to know where you guys are as well. This is a nice way for me to get some info. Okay, so I see there's 5 of us in. Okay, and the first screen, just move the dot to indicate where you think you are in terms of being totally stressed out. That would be -5. To totally relaxed, that would be a 5. Okay, and then try and use words to explain how you're feeling about this experience. Does everybody see that?
Yeah.
Good. Josh, you good with that?
Yeah.
Isabella, are you there?
Yeah.
Okay.
Where you be? Okay.
Okay. When you're done that, you can move on to the next screen. It asks you to locate where in the world you are. So just move the dot so you can see where you are. And then the very last screen just asks you for your the time difference. So I know a little bit. Oh, there's Ryan. Oh, and Queenie. Are you there, Queenie?
Yeah, done.
No, she's not on Zoom, but she's on the Google, on the Student Desmos.
No, she is on Zoom.
Is she on Zoom?
Yeah. There's also Elsie.
Oh yeah, 10 participants. She's there. Okay, I can see. Beauty. Excellent. Okay. So give everybody a second to finish that, and we're going to take a look at some replies in just a sec here. Let me get this out of the way. Okay, Dasha and Sky, go right ahead to the next screen if you like. Show me where you are on the planet so I know where you're coming from.
Oh, where we are on the planet?
Yeah, so if you go to the next screen here, you just have to move the dot to where you are. I'm here in Ticino, so I'm gonna just move this dot to where I am,
Oh.
okay?
I don't know how to find Ticino, but okay.
Well, just put it somewhere in the middle. You have to be precise. Okay,
Wait, where's the survey?
are you there, Emily?
Where is this survey?
You need to go to Student Desmos and type in the code here at the top of the screen. You see NK3 GP6,
Yeah.
and then you can start. Okay, there's Emily. Give us a rating, Emily, from -5 to 5 on how you're feeling about this whole experience of distance learning.
Right now?
Yeah, right now. -5, you're totally stressed out. 5, you're totally cool. And then you can express yourself in words. Okay, and we're going to take a look at this in just a sec. So it's pretty good. If you look at the overlay, I can see lots of people are on the positive side of 0. Nice. So the majority of us are feeling somewhat positive about this experience. And if I look at some of the comments, Giorgio thinks it's interesting, could work well. Josh isn't sure if you'll be able to do as much work as we would do in class. Yeah, that's probably true, Josh. I don't think we're going to be able to do as much work together in a classroom situation like this one as we usually do. You know, it's going to require you guys to do a little bit more work on your own. Does that make sense, Josh?
Yeah.
Okay. Isabella's okay. Dasha says, I'm trying to keep track of all the assignments, but I'm trying to manage my time wisely, not to stay behind, and that's what worries me a lot. Yeah, it's going to be a bit tricky to manage your time here. Try and use Google Classroom as best as you can and organize yourself. Adela says she's stressed. Okay, Adela, I'm glad you're here. We're going to help deal with that as best as we can. Queenie is fine, and so is Elsie. Ryan thinks this is good, and Emily says, I don't feel too stressed, and I enjoy self-studying. Fantastic. This is going to require a bit more on you guys to do stuff on your own, so hopefully you're good with that. If not, we're going to develop those skills over the next couple of weeks, okay? Now, where is everybody? This is important for me. I know, for example, that Fiona's in the United States of America, and that makes it hard for her to zoom in. Oh, we didn't. I thought we would get an overlay with everybody's dot here. I didn't think so. Let's look at the responses. So a lot of people here. Can you guys see those small dots? Are in the same time zone. Della zoomed into Albania. Okay, so Queenie and Elsie are in Asia, and Ryan as well. Okay, so basically we've got 3 people that are ahead of us, and everybody else is on the time zone. And poor Fiona, she's behind us. So right now it's too early for her to chime in with us. Okay, so I asked you guys to give me your time zone difference, and basically you can see where we're at. That's pretty positive. Okay, that's good for me to know. Any questions with that you guys have? No? Okay, good. Let's just continue on with this presentation. Today, like I said, for those of you who came in late, I'm going to spend a lot of time just talking about the logistics of this. It's really important we get this down. If you have a question, just raise your hand and say something out loud and interrupt me, okay? Okay, so we're going to be using Google Classroom. Hopefully everybody's found the Google Classroom. I'm just going to go to it for a second. We're not using VeraCross, and the reason is I think Google Classroom is going to make things easier for you to submit. Up until like, I don't know, Thursday or Friday of last week, there was no submitting on VeraCross, and then that changed, In the meantime, I already set up the Google Classroom, so take a look at this Google Classroom, make sure you're acquainted with it. The best thing is to go to the top here where it says Classroom, okay? There you can see things more in order. I'll try and order things chronologically. I did load up the textbooks, okay? So you can get them here whenever you need them, okay? Formula booklets up there as well, okay? Now this is a link to the past papers. We're gonna be moving to those next week, okay? And I did update them and hopefully I've got everything right there. What's really important is the homework help, okay? So the homework help, I changed the format a bit. Hey Omar, how's it going?
Hey, how are you?
Good. I've changed the format of the homework help. So if you notice when it loads up here, it's taking a bit of time. Please put in the exercise set, okay? Because we're not going to meet as a group to talk about this too much. So I can't say in front of you guys that this question comes from Hayes and Harris example, exercise F. So if you could complete that, that would be great. I'll put in links to the solutions. Okay, so 3 were loaded up over the weekend and I solved them last night and I put the YouTube links here. Okay, has anyone looked at those yet? Nobody?
Yeah.
I've watched one.
I watched
Okay.
one of them.
Hopefully you're okay with those. I don't want to use our time here on Zoom to be talking about too much homework. If you don't get the solutions that I posed, then we can make an appointment or something like that to meet, okay?
Hmm.
All right, meeting time. Here's our schedule, okay? We're gonna have probably 3 Zoom meetings a week, probably 4 this week because it's the first week, but generally speaking 3. And I like this time, but I also like Wednesday and Thursday. I think Wednesday, especially Thursday, gives Fiona a chance maybe to chime in. I think she's only 4 hours behind right now because she's in Boston and I think they switched to daylight savings time before us. So she might be able to chime in here, but these are the Zoom meetings, Mondays, Wednesdays, and Thursdays, okay?
Okay.
On Tuesdays and Fridays, I'm available by appointment, okay? We also have the regular office hour times where I'm available, but we have to respect the school schedule, okay? Any questions with that?
No.
Okay,
How do
Giorgio.
we schedule a call with you? Do we write an email?
Oh, yeah, send me an email. Send me an email. I will be available in those time periods. So if you can send me an email, that'll work. You'll see in a sec that I already want to talk to people tomorrow about their IAs. So tomorrow's time period will probably be dedicated to that. Okay?
Yes.
You send me an email, and then if those times don't work for you, we'll try and meet otherwise.
Okay.
Emily, question?
No.
We're good? Okay. The last thing that I want to talk about, and this is important. Wait, did I get all those? Yeah, office hours, good. Internal assessments, okay? So your IAs really need to get done. We need to get those done this week. I know I've spoken with 2 people already on the weekend. Giorgio and Omar, are you guys good to complete this by Friday?
Yeah.
Hopefully, yeah.
Okay, the rest of us need to have an appointment to finalize things. I need to get these done by Friday. Mr. Stickley would like me to have all the marks in and the sample generated by the following weekend, okay? I need to get all this done by before the spring holiday. I can't go on the spring holiday without the sample being submitted. So I'd like them to come in by Friday this week. Anything after Friday, I'm going to be hounding you down to get those IAs done, okay? So if you need to meet with me at the end of this session, send me an email, okay? Don't send me a message in the chat because I'm not sure where that goes at the end. Send me an email and then we can discuss that, okay? Does anybody have any questions about the IAs? Okay, good. Okay, so that's pretty much it. Oh, the exam review course, yes. How many people were thinking about doing the exam review course? Can you just show of hands if you were? Nobody. Okay, so, all right. So that can still go ahead. Mr. Stickley and I were talking about it, and we're gonna see how the next couple of days goes. I mean, online learning for me is new as well. So if we can settle down a good formula, let's say between videos and independent work, what I'm proposing is to create some short videos for you to watch and then have me available in this format to interact with you about past paper questions over that weekend. So that may still go ahead, most likely will go ahead. Question?
In the Zoom meeting, get the hell out of my room.
What's happening?
Someone's got their audio going there. If I hear something, I'll stop. So no questions? Okay. Oh, I see. I can hold on a sec, guys. I'm just learning something here about the. Oh, can't see everybody's picture at once. Ah, there we go. Now I can see everybody who's got their video on. Good. So if that course goes ahead, I'll let you guys know soon. Okay, probably by the end of this week, and it probably will go ahead, and we'll cater that to your needs, right? But at the end of this week, we should. Emily,
Will it be at school or online?
it has to be online. We're not allowed to have students in school. So it'll be online. I'll record short presentations about topics, give you some questions to work on, and then we can interact on a one-on-one basis or in this way to help you settle those problems. We can't do it at school because we're just not allowed to have students here. It's against the rules, against the law. Yeah? Any other questions? Giorgio?
No.
Okay, good. Okay, so we're going to start looking at past paper questions next week. But for today, I wanted to, one thing I didn't explain was the handing the homework in. So you guys can see my Google Classroom now, right?
Yeah.
Can I ask you, can you see the pictures of yourselves on my screen? No.
No.
Yes?
No.
No.
Okay, good. So that's not available to you. Perfect. So for the homework that you're supposed to hand in, we go to classwork. You were supposed to hand this work in today. I need you to hand things in kind of on a daily basis so I can keep track of what's going on. Okay, so this homework exercise was due today, right? Student work. I think Elsie handed it in. The rest of you guys, if you could take pictures of your work and preferably scans and put them in here, then I can see that you're working on this and I can give you credit. Fair enough?
So we turn it in on Google Classroom.
Yeah, turn everything in on Google Classroom. That's the reason why we're using it. Yeah? If you don't have a scan app on your phone or a scanner at home, I would recommend doing the scan. Taking photos sometimes is difficult for me to actually see what is going on. Good?
Yeah.
Okay. So if we go back to the Google Classroom for the classwork. So today, what we're supposed to be looking at is definite integrals. Did you guys take a moment to look at the PDF? If you didn't, you can download it here and connect and get it. Do you guys hear me okay?
Yep.
Okay, because it's starting to give me messages, something about my internet connection, but as long as you can hear me, that's good. Okay, so what we're gonna do is I uploaded a video and I'm gonna spend the rest of the time going over that as much as I can with you individually right now, as a group, sorry, not individually. And then if we don't finish, because we have until 11:05, then I suggest you watch the video. And then the questions that you should be doing on this for next day are right here, 6.10 homework exercise. It's only 5 questions, okay? So I'd like you to do those for Wednesday. And on Wednesday, what we're gonna look at is this fundamental theorem of calculus. Okay, this is really important. There'll definitely be some sort of exam question about this. So if you can download these and get them ready for Wednesday's class, we'll be having a look at those. I'm going to try to make a video that you can watch before we talk about the lesson, right? So I want to flip the classroom around. So I do videos that you watch before, and then we discuss the results together as a group, okay? Now, I don't think you watched this one, so we're going to do it together as a class. So to do that, I have to stop sharing this, yeah, and I am going to share something else with you Okay, so yeah, I'll give it a sec. In just a second. Okay. All right, can you guys see my iPad screen now?
Yeah.
Yeah? Everybody good? Okay, so we were looking at definite integrals. So I've annotated these all from yesterday, so I'm going to erase some of those annotations and work again with you on them. Has anyone watched the video by chance? No, not yet. Okay, so what we're going to look at in this is actually just a review of things that we had done before. Okay, so put this over here. We had done Riemann sums before, and this is more a general version of Riemann sums. So if you have these notes, that's great. Next time, if you don't, print them off so you're ready to go. But basically, as you guys remember, the problem is to find the area under a curve, right? Can someone tell me, how did we do this before? How did we find the area under a curved region above the x-axis?
Integrate.
Yeah, okay, but before we integrated, we did something else.
The rectangles.
We did the rectangles. Good. We need to know the rectangle thing. When we did this in the core, I said, oh, well, the rectangle thing's important for us to understand some of the harder exam questions. In the option, we're responsible for the rectangle thing. Okay, so how does the rectangle thing work out? Well, this is a more general version of the rectangle thing. And basically, if you remember what we did, let me just erase what I have here, okay? Okay, so we're trying to find the area between A and B above the x-axis and under the graph, correct? So what we did before is we split up the region between A and B into equal intervals, okay? Well, in general, you don't have to do that. You see, we could divide that space into unequal intervals. So it could be like, the first one is always x0. X1 could be really close to A, but x2 could be over here. X3 could be there, x4, and then maybe I only have 5 spots, and hence 1, 2, 3, 4, 5 divisions, and they're all different widths. Okay? Now, if they're all different widths, that's fine, but we know that we have to order them so that they start with the lowest and go to the biggest, okay? So here, what I'm saying is that these two actually, the widths are not equal to each other, okay? We can summarize that as a partition, and the partition just means that division of the interval AB, and we just list all the points, x0 to xm in this case, and that's called a partition, okay? So in this particular way that we're doing it, this is a more general way of doing Riemann sums, the distance between the two adjacent x values is not constant. So before we wrote delta x, which we're going to see in just a second down below, but now we have to write delta xi because that interval width isn't the same, okay? Another complication is that if you remember, we use the right-hand edge, right? We use the right-hand side to get the height of the rectangle. Well, here in the more general case, you can actually pick any point, okay? So any point xi in that interval can be used to find the height of the rectangle thing. Okay, so let's just take a look. I could be looking perhaps at, let's use a wide one where I have more space. I could be looking at that rectangle here, and I'll use a different color. I don't have to use the right-hand edge, okay? I can use any point in the middle. And I can get an area like this, okay? So you see here, you'd have the change of x2, okay? And for the adjacent rectangle right next to it, I'd have a different delta x, I'll call that delta x3, and I could pick maybe I'm gonna pick the endpoint this time, okay? And then I'll use the endpoint to get the area of the rectangle, okay? And so if we just call these points that we're using, so this one is x3 star, but this one in the middle is x2 star, then their heights are f of, this height here will be f of x2 star. And this height up here will be f of x3 star. Okay? And if I multiply the heights by the widths, here you can see I have an expression for the area of each rectangle. And then if I add them all up, I have what's called a Riemann sum. Okay? Don't worry too much about this. You're never ever going to have to do the Riemann sum with any old width and any old point in the middle. It's just good to be familiar with that. What we're going to be looking at mostly is the upper Riemann sum. This you're required to know about. And the upper Riemann sum is just when the f of xi is coming from the maximum value. Okay? And the lower Riemann sum is when you're taking the height of the rectangle from the minimum value. Okay? So if the function's increasing like we have above, where would you find the minimum y value? On what part of each one of these intervals would you find it?
The
Anyone want to take a stab at
left-hand
that?
edge.
At A.
Well, okay,
Left-hand
the
edge.
first one would be at A. In general, where are they going to be if I want the minimum?
Oh, like left hand.
The left.
Yeah, on the left hand, okay? So the lower one can mean the left hand if the graph is going up. What if the graph is decreasing?
On the
Down here
right.
I put a decreasing graph,
On the right.
right? On the right, okay? So don't get the L to mean left or right. It means lower sum and U means upper sum, okay? So the upper sum, you're picking the maximum Y value, and the lower sum, you're picking the minimum. Does anyone want to ask a question about that before I go further? No? Okay. All right. Can Elsie, Adela, Ryan, and Queenie, can you hear us? Can you send a message in to let me know that you're there? I just see your picture.
Yeah. Here.
Sure, I don't.
Adela's there, yeah. Elsie?
I'm here.
Queenie, is it
I'm
working?
here.
Yeah.
No, I have a really quick question. I don't exactly understand the f of xi with a little star. Like what?
The
Yeah,
star
what's
just
the
means you're
star?
picking a point between xi minus 1 and xi.
Okay.
So in, for example, here, Josh, in this little bit here, if I can draw your attention there,
Yeah.
it's just some point in the middle.
Okay.
Now, if you're doing the lower sum, it's the point in the interval where you're getting the lower value, the minimum. If you're doing the upper sum, it's where you're getting the maximum.
Okay.
Yeah? So if the graph did something weird like this over the interval, so that's x minus 1 and that's xi, then the upper sum would come from this point here, and I guess the lower sum might come from that point there.
Mhm.
Good? Okay.
Mhm.
Now,
Okay.
regular partitions are all you're really required to know. So let me erase some of this stuff that I added in last night. So regular partitions are what we're going to be working with. And that's when you're taking your interval between A and B and you're splitting it up into equal widths. Okay? So here, can you cross that off? This should just say delta x. There's no delta xi anymore because the width of the intervals are equal all the way along. Okay? So there's your delta x. So we're going to split it up into equal bits. In which case, if you're going to have n subintervals, their width has to be the distance b minus a divided by n. That we saw before.
Yeah.
Yeah? Okay. And then the Riemann sum, well, if you look at the Riemann sum that we had before, be it the upper sum, the lower sum, or any old sum, it should be I goes from 1 to n of x of I star delta x. Well, we had a delta xi here, but in fact, that's now a constant now. So that Riemann sum is the delta x, which is b minus a over n. That's a constant. And since it's a constant, we can pull it outside of the summation sign, and that's what's happening right here. Yeah?
Mm-hmm.
Okay, now, if you let n go to infinity, we know you're going to get the actual area. And what we're going to say now is that's going to require that the upper sum and the lower sum be equal to the same limit. If that's the case, then we say that the area is the value A, okay? And in fact, we gave it, you'll see just a moment down below in the notation, we called that thing this symbol here. This is a real number, and it's equal to this A value. And that's what we meant by integration, okay?
Mm-hmm.
Okay, so right now we're going to look at an example to remind you guys how that works out. Okay, so, but to do so, we might need some of these summation formulas, which we've seen before. We actually proved them by mathematical induction, okay? So I'm going to erase what I wrote on last night and start over again. Now, I got a bit
So
late.
can you
Hmm?
could
You
you
wanna
go
see
up
this?
for 2 seconds?
Yeah,
No. Sorry, my thing is in the way, that's all.
yeah. Move your thing out of the way there.
Okay, thank you.
Okay?
Yeah.
All right, so I was erasing all this. Okay, and like I said, if you want to look again at the notes, you can online as a video. I'm not sure we're going to finish this stuff all today, so you might have to watch the last little bit of the lesson on your own. Okay, so here what you're asked to do is the upper Riemann sum and the lower Riemann sum. Okay, and you are required for those to understand those differences between upper and lower sum for the exam. What we have is this is the graph of y equals x squared plus 1, and we're trying to do the area between 0 and 4. Okay, so I cheated last night and put Desmos graph, and you can just draw one on your note as you need to. And we have to find the upper sum, okay? So first, we're using a regular partition. We're always going to use a regular partition, I think. You know, the extra bit about irregular partition is just an added piece by Hayes and Harris to enhance your knowledge, but you don't really need to know that much about it, okay? We have 10 minutes left before I gotta go to my next class. So the delta x, the formula is b minus a over n, okay? So in this case, the b is 4 and the a is 0, so the delta x is just gonna be 4 minus 0, or 4 over n. Make sense?
Yeah.
Okay, so let's look at one particular, I'm gonna just give us a feeling for this by partitioning this interval. I think it's got 8 subintervals if I do it this way. I'm gonna pick on one here. Let's pick on one that's kind of big here in the middle. Okay, so first we gotta get a formula for xi. Do you guys remember how to find the formula for xi? No? No one remembers? We're going to start with the a, and then we're going to add multiples of the delta x, right? So if I were 0, you're just going to get the first point as a. And then we're going to add 1 unit of delta x when I is 1, right? So if I is 1, x1 will be a plus delta x. If I is 2, x2 will be a times 2 delta x, right? So it's just an arithmetic sequence. You're adding bits and pieces of delta x as you go along. When you get to the end, xn, so dot, 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 will be a plus n delta x. But look what n delta x is going to be. 4,
Wait,
right?
just for a
So
second.
you're just going to have n plus n times b minus a over n. They're going to cancel out to give you b. Okay? So that's how you get the xi's. Then to find the let me erase some more, give us some more space here. To find the upper sum, what we have to do is look at the, so in our particular case, sorry, xi is a, which is 0, plus I times 4 over n. It's just 4i over n, okay? And to find the upper sum, we have to take the maximum value, which, since the function's increasing, will always just be xi. So if this is xi, and that's x minus 1, the xi star for the upper sum will just be xi. So to find the upper sum, we're going to add up okay, all of the areas, oops, as I goes from 1 to n. Okay, and each of those areas, okay, is going to be the f of xi star times our delta x.
Wait, why is I star xi?
Because we're
Xi.
using the upper sum, it's an increasing function, so the highest value is always going to be on the right.
Oh, okay. So right now we're doing with the upper
Upper.
sum.
And then we'll do the lower. And we have to show that when you
Ah.
take the limit as n goes to infinity to the same. Okay?
And the lower would be xi star equals xi minus 1.
Precisely. Okay. I'm not sure we're going to finish that, Josh. So I encourage you to look down below on the video. But once we get the right-hand one, I think the left-hand one will be pretty easy. Or the upper sum, the lower sum will be pretty easy. Okay. So xi star is right xi because it's the max is on the right. Yeah? So we want to go the sum of, well, xi, we just figured out was 4i over n times delta x. Okay? And our function, if you recall, is x squared plus 1. Okay? So I goes from 1 to n of 4i over n all squared plus 1 times our delta x, and the delta x in this case was, do you guys remember what it
4
was?
over n.
4 over n, good. Okay, so this is the summation that we want to evaluate, okay? Now 4 over n is a constant, doesn't involve I, so we can bring that outside. And then we have inside the summation 16i squared over n squared plus 1. Okay,
And you find the xi always by the same method, so a plus I delta
Yep.
x.
that's right. That's right. It's up at the top of the note. That's exactly right. Yeah. And so now we have to evaluate the sum. To do that, we're going to split it up into two parts. Both parts are going to get multiplied by 4 over n. Okay? So the first part, you can take the 16 over n squared out and just sum up the I squares. And we have a formula for that above. Okay? And then the second part, we need to just take 4 over n and multiply the sum of the number 1 n times. Okay? So we have 4 over n, and then we have 16 over n squared, and then this, the formula above told us was n plus 1 times 2n plus 1 all over 6. Okay, and then the second one is 4 over n, and what happens when you add the number 1 n times? You just get n. Okay, and so we can simplify this a bit further. I'm going to erase this. You'll have to check this out on the video tonight because I moved the space. Okay, and so if we simplify, we're going to get the first expression of 64 over n cubed, and then there's this other thing over 6. We multiply this bit out here together. Okay, we're going to get a 2n cubed plus a 3n squared plus n. That's multiplying these brackets out. And then the other one is just plus 4. Okay, and I mean, this is simplified good enough. This is the upper, the upper Riemann sum. What we want to do is ask ourselves before we quit in a couple of minutes, what's going to happen to that upper sum as n goes to infinity?
Okay.
What's going to happen to this expression right here? You
Goes
got
to
n
4.
cubed, and on the bottom you got n cubed.
Yeah,
No.
so to 2 over 6.
128 plus
What's this limit going to go to here?
I think it goes to
One
6 now.
132.
Well, it goes to 64 times 2 over 6, right? The n
Yeah.
cubes are the only things that matter, right?
Yeah.
If you want to rewrite it as 128 over 6, and then what do you have? N cubed plus n 3n squared plus n. Sorry, I need to write this as 64 and keep the 2 there over n cubed. Okay, this is just going to go to the number 2 because everything where the power is smaller than the one on the bottom, that's going to go to 0. Okay, so this goes to 64 over 6 times 2, and then of course 4 just goes to 4. Okay, so I believe we get 64 over 3 plus 4, and then if you simplify that as a common fraction, it's 70. As one fraction, it's 72 over 3.
Wait, why do we keep the 4?
Well, because the 4 is a constant on the end. I mean, the limit of the constant is just going to be 4. There's no n there, right? We're taking the limit of
Okay.
this expression as n goes to infinity. So the only thing with an n is here, and you guys know it's the ratio of the highest powers to
Yeah.
the limit. So we end up with 72 over 3. Yeah? That's the upper sum. Before we stop, I'd like you guys to try and do the lower sum on your own and
I
watch
think
the video
76.
on your own. Okay? The video will take you through all of these notes. Dasha?
I have a question about homework, because you send an email, like there's a table with like improper integrals, homework, new, Hansen-Harris, I think it says.
Mhm.
Yes, so I was supposed to do this one or the one which is assigned on Google Classroom. I don't get it.
Just the Google Classroom. I didn't send you an email. If you got an email, it could have been Google Classroom automatically sending you one.
Okay, so we shouldn't do, should we do the assignments from this table from email?
Let me show you. So I'm going to stop sharing that, and I'm going to share my desktop. Okay. So you should do in the classwork this exercise here, 6.10.
Okay.
Yeah?
Okay.
First watch
So
the
this is the
video.
homework.
Yep. So what you should do is watch this video here, definite integral. Just go to the part that we didn't get to, and work your way through the notes, and then try the homework exercise. Okay.
Okay.
On Wednesday, okay, there'll be another video to watch on the fundamental theorem of calculus. Just watch the video the day before, and rather than me going through the notes bit by bit, I'll just ask you questions about them as you go through them. Okay. So that's what I mean by flipping the classroom around.
Mm-hmm.
Is that good? Does anybody else have any other questions?
But are today's homework about this or something else?
Today's homework is about what we just finished.
Okay, perfect.
Yeah? So just do a little bit more reviewing on your own and try those 5 exercises. Now, if you haven't talked about your IA yet, I'm going to send you an email this afternoon to check in with me tomorrow at our class time. Okay? So that's like pretty much everybody. Okay, so I will try and work something out so that we can talk about that. If you have a draft already, please send it to me. Some of you guys have done that. Even if it's not totally complete, and that can be the basis for our conversation tomorrow. Okay?
Okay.
Are any other questions before we break off?
No.
Okay, I can see my grade 10s are coming onto the same thing. I'm gonna have to get a different code for them so they don't come into the end of our lesson. And I'll see you guys, if I don't see you tomorrow, we're gonna meet up on Wednesday. Unless you really need to talk to me, send me an email, okay?
Okay.
All right,
Mhm.
hope that was good.
Bye-bye.
Bye, guys.
Bye.
Goodbye.
See you, bye, bye.
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 How do we do this?
Bye, guys. Have a good day.
No idea how to.
How do you do this?
How do you do this?
Close it.
End.
Stop video. Now.
Okay.
Cannot.
Leave meeting.
Just go to leave meeting. Bye, Sarah.